campaign in my office to get some new folks trained on ambient air monitoring. So we've been doing a whole series of trainings internally. So this was pretty fortuitous timing for us, really. So I'll just introduce myself. My name is Chris Hiltunen. I am the president of Bison Engineering. We are located in Helena, Montana. We have 2 offices in Montana and 1 office in Tucson, Arizona. We are air quality consultants. We are stack testers. We have an ambient air monitoring group, and we actually manufacture some stack SEM instruments. We are kind of a regional player. We mostly work in the western half of the United States, but we take wherever our clients take us, we will go there. I had a compatriot that was supposed to come present with me, and he's lost in airline world right now, so he ain't gonna make it, Jake. So we'll just get going. But if you guys have questions, you know, I'll try to go as deep as you want. Okay, it's just like hit and miss on this thing. So just I've listed here a whole host of reasons why you might monitor ambient air. We have done at my company all of these things over time and I'm coming at this from an industrial perspective. So I'm not a regulator. I know, you know, the states, the feds, sometimes local agencies, they have their own monitoring programs. I've kind of angled this from you have an industry and you are monitoring or you want to monitor. These are the reasons why we have operated monitoring stations for clients, and it's kind of everything under the sun. But these new regulatory drivers have kind of pushed some work our way. You know, fence line monitoring for benzene, that's been around for quite a few years now for refineries, etc. As an example. But increasing social justice, kind of, I think what you're getting at is states, and I've got some slides on this, but states are getting after this, the feds are getting after this, communities are getting after this. This is becoming a very important issue of, you know, environmental justice. Are industries adversely impacting, you know, low-income neighborhoods or maybe neighborhoods of color, or, you know, is there some class that's more adversely impacted by local air pollution? EPA, this is on Biden's mind. They talk about this stuff all the time. They're going to throw some real money at this. But there's a lot of reasons why you might monitor here. So just wanted to mention, I think you guys are aware, but there's a lot of interest on the national level. Environmental and social governance, environmental justice is driving a lot of changes. And the EPA is coming to realize, and the states are coming to realize, that while they operate a fleet of monitors, there's a lot of places where there isn't much data, especially in urban areas. Most cities have 1 or 2 monitors somewhere, you know, MET, particulate PM10, maybe VOCs, maybe ozone, maybe NOx and CO, maybe some more specialty pollutants if there's some local concern. But when you map it out, there's not a lot of data. And so this is really coming to the forefront, and EPA and the states are really looking into this. I just put this last point. I know it's wordy, but some of the COVID money, the American Rescue Plan, put $100 million towards local monitoring. So they've just injected that money into EPA, who's doling it out to states, counties, and communities in the form of grants to do their own monitoring. Just doing a little searching the other day, there's tons of stuff like this online you can find, but Senator Markey from Massachusetts, and I'm actually from Massachusetts, so this brings a little home to me, but is proposing $100 million a year for 5 years. So $500 million for what they call hyperlocal, kind of a dense network of local, perhaps community driven monitoring. I don't know what the chances of this passing is, but I think if this doesn't make it, something else behind it will. They are willing to throw a ton of money at this. I think communities are clamoring for this. I think the feds are clamoring for this, and maybe regardless of the mechanism, this kind of thing is happening. So this next slide, I guess my train of thought is, if I'm in an industry and I might perceive that environmental justice might be pointed at me, I should think about maybe I should be aware of what the ambient concentrations are around my plant. Am I a target? Are the feds, is the state going to come looking at me? They're going to deploy all this monitoring. If I'm the only industry in the neighborhood, they're going to come sniffing around and knocking at the door someday if they think the readings are high for whatever pollutant we're talking about. I've angled this a little bit at particulate, and you'll see that as we go, because I think that's the one of the easiest ones to point at for impacted air, especially in urban areas. I'm from a rural area. This is one of our monitors. That one's actually in Florida, actually, but wildfire smoke is a huge concern. And I'm going to cough at some point during this because I've been living in horrible smoke for months now, and it's getting to me. And I think that's kind of the same reasoning in urban areas. Is sometimes the air is not that good. I've been looking at Austin for about the week before I get here. It's not that good. And I don't know if it's smoke or if it's just how it is here. And we'll get to a slide towards the end just that talks about and gets at some of the numbers here. But I guess the gist is, if you've got a plant, you're surrounded by a lot of neighbors, especially if they are noisy about what you're doing, it might behoove you to know what the ambient air around your plant is. And maybe you could monitor, or maybe you could find some data that somebody else is performing the monitoring for. Yep.
How do you feel about, I wrote down that it struck me like sort of a catch-22 industry monitor, but you perceive that I might have a problem with the Russian monitor. And I think the second thing is monitoring side, there is like versus some of the local personal monitors.
Sure.
So I'm going to also caveat this by, I do air quality consulting, have clients that are industry, like power generators. I actually do have one where I technical for environmental justice.
Okay.
So it's sort of interesting. I'm in a lane.
Right. Well, it is. Well, I'd say a couple of things to that. Firstly, I think these grants are going to go out neighborhoods, local, other people are going to be doing the monitoring. So why not you have some data up front, and then you'll be able to kind of see and know what they're going to get. And if there is a problem in the neighborhood, I think you as an industry, you need to know that. And because again, I think other people are going to figure this out and they're going to come knocking on your door. So to me, this is kind of an early warning of, if you're stinking up the neighborhood that badly, you need to know that. And I think there's a lot of plants out there that kind of have the blinders, like, it's really hard to prove anything with ambient monitoring. And we'll get into this because you're really looking at ambient monitoring standards, and this is not, stack emissions. Ambient monitors are not super good at even if you're downwind, at getting exclusively what's from a stack. It gets what's in the neighborhood. It takes a slice of life in that area. So it's hard to get, let's just say, pinned in court or get an NOV out of anything that you could do with an ambient monitor. But what it does do, I think, is alert the locals or the feds that, if you're blowing ambient standards downwind of your plant, there could be a problem. And since there was no data and there was no monitoring before, everybody just ignored it. But now there is going to be more monitoring, so you might as well be ahead of it because they're going to catch up to you. Yep. That's my thing, and maybe that rings true to you. So I was just going to point out, and I've got some maps at the end, but there is a ton of data online, and I guess one of my points is just before anybody goes out and sets up a big ambient monitoring program now, I think it behooves you to do a bunch of research and see if others around you have beat you to the punch, and maybe they're monitoring around you already in either official or semi-official or maybe not official capacity, but you could save yourself a lot of time and money by looking at data that others are generating around you. I was going to ask, your monitoring, is it required by permit?
Just now, it started out as a SEP and then
Okay.
ended up.
Okay. You know, that's one way to do it, the fun way, right? I don't know if you are aware of some of these things, but there's actually a ton of data, and there's more every day, because these, especially, and I use this purple area, you'll hear me talk about this. Are you guys familiar with those? They're selling those things like hotcakes, and they're everywhere. And we've actually done some studies, some comparison studies, and I've read a bunch of studies online. And while they're not perfect, they're actually pretty good. And the wildfire smoke around us is so bad, we have found some studies that give some kind of conversion factors that, you know, they're light-based, so they don't respond. They respond to particle size and not mass. So there can be some conversion factors, but the little cheap purple air things, it's a real thing, and there's a ton of data online. You know, why not use it, take advantage of it? And then same thing with the MET. You know, there's a lot of stations out there that don't, or plants that don't have a MET station. I think everybody should have a MET station at their plant. But there's a ton of MET data online. Feds are on a huge network, and that RAWS site conglomerates all of the federal agency monitors. So that's everything. BLM, Forest Service, EPA, everything the feds do gets fed into RAWS. So I just throw that up there, that there's a ton of data out there. And maybe one of your industrial neighbors is monitoring already, and maybe you could just buy into their network instead of building your own. I've seen that done quite a bit. So I guess the point is, again, just it's one way to see what's out there, but just by seeing what everybody else has done before, maybe you go out and build a station. I was just going to talk about the NACs a little bit. Are you guys familiar with the NACs? Not every station out there is capable or would be used for judging compliance with the NACs. But I think it's important to know that when we're monitoring ambient air, these are really the standards that you could compare it to. Most states and some local agencies have their own standards that are more stringent than the NACs, but of course they can't be less stringent than the NACs. Occasionally we're looking at PSD increment, although that's usually demonstrated by modeling and not monitoring, but sometimes there's a little ground truthing that goes on there. And then some of the states have TAPs or HAPs or other names for more specific compound standards. Or do you have some standards that you're being held to there? Yeah. So I just think it pays to know what the official standards are that you're monitoring for before you get there. Just a little bit on NACs, maybe you guys know these things, not everybody does. Obviously put out by the EPA. Each NACs pollutant is a criteria pollutant. I guess that's how I refer to it. Everything that's not a criteria pollutant is a HAP. Some states have enormous lists of TAPs or HAPs that they want data for at this point, or maybe they want health risk assessments for emissions. Obviously, that's all listed clearly in the CFR and other places. Data quality objectives. I think kind of regardless if you're going to go try to snoop some data off the internet or, you know, run a station, you really want to have some clearly defined data quality objectives before you go do any substantial amount of work. Sometimes these are laid out for you in the permit very clearly. Sometimes it's not clear at all what standards you're being held to. So I've kind of thrown a couple of levels of, this is kind of my terminology, for the industrial side, and this is not for the regulatory agency side, but to me, the best The gold standard of monitoring data is PSD quality data, I'll call it. So you have to meet the federal QA guidelines, and in addition to that, you have to meet the PSD pre-monitoring guidelines as well. So if you are doing a major modification or you're going to build a greenfield major source and you need to do pre-monitoring, you have to provide PSD grade data to your state agency. So that's the top tier. And then what I call regulatory grade would be, state permit required monitoring, where you're still held to the federal QA standards, but the PSD guidance is not necessarily applicable. So it's a little bit of a step down. And then metadata for dispersion modeling. Normally you need to be following the federal QA guidance, but not always. Sometimes the states let some really weird data sets slide through for modeling jobs. And I don't totally understand why, but if you can talk a state into using whatever metadata set you can come up with, sometimes they will let you. But I think a lot of what we're talking about now is this more community oriented consumer grade data, I'll call it, where there's just a lot of samplers and maybe they're not deadly accurate, but they're pretty good. But all of a sudden there's a big body of data and sometimes it's hard to argue with that. If you've got, instead of one federal reference method standard sampler running, you've got 50 purple layers, for example. Those 50 purple layers can tell you a lot of information. I think the other objective you need to think about if you're going to run a monitoring program is just how complete does your data need to be? Again, for PSD pre-monitoring, completeness is a very important component. So they are absolutely expecting a 90% completeness for a year data set. It doesn't have to be a calendar year, but whatever year, if you started on whatever, June 2nd through June 1st next year, needs to be 90% complete. And if it's hourly data, that's number of hours over 8760 in a year. The state required regulatory monitoring, usually permits hold you to a 75 or 80% data completeness requirement. Still pretty useful. Just wanted to point out for modeling, if you're using any metadata for modeling, that is probably the most strict completeness standard you have to comply with. It's 90% complete by month and by year. So if you think about that, 90% by month, if there's 30 days in a month and whatever, your tower gets hit by lightning and it explodes, if you miss 3.1 days out of that month is invalidated. And then if you're trying to have a year of metadata for modeling, that year just got blown out the window. So now you're starting on the day that station comes back up. Now you're starting on your year then. That puts people in a pinch sometimes for permitting efforts. If you're waiting for a year of metadata to run some models to permit a big source, and your station goes down halfway through, you've just blown 6 months of time, perhaps. So it's just really important to keep that in mind for depending on what you're doing, but know what your data completeness objectives are so you can respond to problems. Informational data, I think it's not so important to be complete, but certainly data with lots of holes in it, I think invites questions. Did things slip through when the monitor wasn't up and running? So if you were able to find a data set online, or maybe there's some real-time monitors online around you and you want to look at that data, I just threw out this list of things that I think you should contemplate if you were to try to use that for some perhaps official purpose. There's a lot of data out there. Some of the data sets out there, or there's a ton of sets where you don't know what the background to that data is. So I think it's important if you're going to use the data for something official, or at least quasi-official, that you know the background of any data set that you might download off the internet, for example. We do this sometimes. Sometimes we as consultants find, let's just say, a MET set or some background PM or NOx or ozone. we need to be able to provide the documentation for that data that we get so it's usable. So I guess that's the point, is think about these points. If you find some data sets online that you'd like to use, can you provide some of this or all of this data to an agency that you might be presenting it to? Really important that you can do that. The agency will likely not approve of let's say a modeling set. If you use some metadata and you couldn't cough some of this or most of this up, they're probably not going to approve it, even though you have the set. 11 slides in a 320 slide, so 11 slides in a 30. Maybe you guys are aware of this. If you were to design a monitoring network and we're following 40 CFR 58, these are just some of the elements to consider in your monitoring network. If you're not held to 40 CFR 58, if it's not regulatory monitoring, I still think these are important things to think about as you go forwards here.
I mean, so I was writing that down when we got to the location of the monitors, plus when we're talking about the temporal and spatial collection.
A little bit, yep.
Yeah, because got like there's site, characteristics
Sure.
of that data, or if there's an exception that having less enough. I'm saying this because so the project I have is, and look at a map. Why there's these pairs.
Sure.
And so I'll sort of stop. I'm just really curious about this. Makes me think about industry that's up there, maybe industry.
Sure. And so I have an example or two of that, perhaps. In Billings, Montana, there is 7 major SO2 emitting industries, and those 7 industries actually have a consortium that operates their own monitoring network. And how that network ought to be is, it's kind of a long and convoluted story, but there's been a ton of historic monitoring because they knew they had an SO2 problem. They stink, the SO2 is awful through the 70s. And then starting in the 80s, there was a lot of historical monitoring. There was a ton of modeling done, and sometimes some of those sites were planted where the model said was the hotspot. Some of them were planted because of individual or maybe like an institutional complaint, like a hospital. A couple of them were located just where people thought perhaps it could be bad. But they had a whole fleet of instruments, that ran real time, not in the old days, but now. So there could be a whole host of reasons, but I think that is important to think about, that one monitor in one place over time probably would give you a max for the year that was probably a little bit reasonable, i.e. representative of the max anywhere. But on any given day, at any given time, it's probably nowhere near how high it could be somewhere else at that. So having a robust network, I think, very much adds to the usefulness of the data, and therefore perhaps the conservative nature or protection of the public end of the data. That at least so. A lot of monitoring that I see, plants have 1 or 2 monitors. We're in more rural areas, perhaps with more like constant wind direction. But I would think in some of our clients in more urban areas, they're the ones that generally have a more robust network multiple stations, multiple sensors, tie in with the neighbors, have consortiums, things like that. Another thing to think about if you were designing a network, what kind of instrumentation do you want to run? The federal reference method instruments are generally the more old school standards. They're the de facto standards. There are newer equivalent methods that are typically more real-time type instruments. So the FRMs, like filter-based particulate sampling. There's lots of other kinds. Again, I'm kind of just honing in on particulate for this. You're probably familiar with the old school high vol samplers on the 8x10 filters, and then now the low vols with the little 47 millimeter round Teflon. You probably have seen those quite a bit. Those are FRMs. The equivalent methods are the automated methods that can report real time. You've probably seen either one of these. The machines have to be certified. You have to get your FRM or FEM certified by EPA. They have a sticker on the front. This instrument is a FRM following code, blah, blah, blah. It's got to have the sticker. If you're going to actually monitor for NOx compliance, you've got to use one of these. Or not say NOx, NAX compliance. You need an FRM or an FEM. But there's a ton of instruments out there that are not either of these that are still useful. Probably your machines are not reference method machines, I would assume, on the whole. Yeah. And there is a list on EPA's website of all the machines that are currently designated as reference or equivalent methods. And that list is actually growing very rapidly. There's a lot of new technologies that are being approved. There's a lot of testing going on about, can these new real-time machines equal what the old school machines can do? So that kind of brings me to one of my points, though, is I still think there's a lot of value in non-standard, non-regulatory monitoring. You can still get a lot of data from an industrial standard without necessarily having to meet all of the federal QA guidance. Because again, you're likely not trying to prove compliance with the NACs. You just want to know what's going on in your neighborhood. You don't have to take it all the way. And there's a huge cost disparity, which I'll get to in the end, in terms of how far do you take your quality assurance versus how much does it cost. So at my company, we actually do a lot of what I would call non-standard monitoring, not directly aimed at NACs compliance, but we get at air quality problems anyways. Welcome, since you're the third, I'll just say hello. Feel free to jump in and ask questions as we're going here. I think remediation efforts are a good example of that, where we're really more getting at protection of immediate neighbors, public health. We don't need a really fancy network to do that. We still want to do it in a technically sound way. We still want to have a QA plan. We want to still have SOPs, but we don't have to take it all the way. And I think, to me, this is what the whole environmental justice movement here is doing, is that we can deploy some non-expensive, non-federally approved equipment. It's not official data, but it still tells a really, I think, pointed story. And I'll show a few slides at the end with some maps with some data that get at that, and maybe you've seen those kinds of things. Especially want to point out the MET data, my last point there. My only caution to all this is, if you ever deploy a MET station and you think you might ever use it for actual modeling, run a real MET station. There's a lot of people that put a cheap MET station out. Some of them do a really good job, but they're not compliance grade data and it won't be accepted for modeling. So just think about that. If you run a kind of a non-reference method MET set, you probably can't use it for modeling. So here's some points. I'm told the slide is wordy, but I like it nonetheless. I don't know if you had a hand in your ambient monitoring from the start, or did you come in after it started? There's a lot to think about that you need to put some real time into planning before you start any monitoring. And monitoring is a huge effort, and there's lots of costs, and they sometimes can go forever. And when you total the money and time and effort you spend on that system over the course of 10 years, it's staggering. Monitoring is not cheap. So I think it's really important to plan what you're going to do before you do it. I don't know if you guys want me to walk through this, but I've had experience with all of these things, and there's a lot to it. I guess the main point I'd make here is, whatever you're going to do, write a monitor plan. Please contemplates all these things. And pass it around and maybe get it approved if you can. Even if you're going to do some non-standard monitoring, it's just for your own implementation, just for your own information. Write a plan, that makes it a lot more defensible instead of just throwing a monitor up and doing whatever you want to do. Write a plan and maybe write an SOP and follow it.
At that progression. That is taking the time frame.
Probably at best 6 months, a year. So here's a really timely example. So this is happening in my company right now. So I'm in Montana. We just got a request 2 weeks ago to respond to an RFP. There is a proposed reactivation and enlargement of a gold mine in Idaho. Again, this is a rural example, but they think it's going to be a PSD source. It's going to be a major source. So I don't know what they're doing at this gold mine to be a PSD, but they want PSD grade, PM10, PM2.5, and MET. So they send an RFP, and it goes on and on and on. And at the end, it says, we want this thing up and running in November this year. I'm like, ha! Fuck with that. So they weren't that familiar with monitoring, but first we got to go there and we got to see what they got. We got to come up with a plan that's going to meet their needs. That plan needs to be at least looked at, if not approved, by the state agency. You got to order equipment, and then during these COVID times, equipment does not come quickly. And then it's got to get here, and then we got to go out there and build it, and assuming it all goes well, 6 months, I'd say at least. They want it running before the snow flies. I'm like, there is no way. And we don't want to be up there trying to dig foundations in January or February. So they're like, we'll probably be up and running in May. And they didn't like that. But it's just kind of the reality of how it is. It's kind of this does not happen quickly. So I guess that's my example. 6 months, maybe a year. It's a big deal. So, I really think the planning, you have to take the planning all the way, because otherwise it just comes around and bites you. And it costs you a ton of money and time, and you didn't get anything for it. I think is the ultimate worst case scenario. Any other questions on here? So, 4C asked me to talk about real-time monitoring. I guess I think we all know and believe this is just how it is and how it should be these modern times. But I think a lot of the sites out there aren't real-time monitoring. Do you publish data anywhere real-time? Or does it just get fed out in reports months later?
No, we have some. We have
Okay.
dashboards.
Okay.
In our
Okay, so you're doing it. There's a lot of companies out there that are not doing it.
yeah, we have both. We also have quarterly reports.
Sure. Kind of required. A lot of the other, I've sat through a few sessions already here. You know, I think For fence line and other monitoring, this is kind of the de facto standard, real-time monitoring, publishing data. But for ambient air monitoring, this isn't not so much a thing today, real-time monitoring. And I like to just say, because there's a lot of equipment out there that I think is old school, be it FRMs or whatever, that require manual labor and labs and reporting and QA and data validation or not. And yeah, their quarterly report comes out 45 days after the end of the quarter. And by the time it lands in somebody's hands that actually looks at it, it's months to maybe a year old. So I guess I encourage folks, if they're going to monitor, I think the modern standard is quickly morphing to have this data available real time. And there's a lot to that too. There's a lot of effort and thought that has to go into having real time data availability. But back to the environmental justice end, that's what the public wants and demands. That's what the politicians want to have in people's hands, is real time data. And I think the reason is, this one here, last word there is actionable. I think that's the most important thing here. I think of my job as an air quality consultant. Protection of public health is why I'm here, right? That's really the ultimate goal of air quality work and air monitoring. My two examples here, so in Montana, the wildfire smoke is horrible. The state has a few monitors and the surrounding states have a few monitors, but you can go on there and look and see how bad the smoke is today, right now. Am I going to go for a hike this afternoon? No, the PM10's 250 micrograms. I am not going to go for a hike. I'm going to fall over and cough up a lung. I don't want to do that. To me, that's the whole point of having real-time data, is it's actionable. I don't know if you guys saw what 4C is doing here with this SGS Galson machine. They sent me the flyer the other day. I think this is an awesome use of some kind of real time. Granted, it's indoor air monitoring, but link it up to a system, publish the data, send out alerts if there's problems and make changes. That's the whole point to me of real time monitoring. So all the QA and the reporting, that all still needs to happen. But I think having actionable data, perhaps distributed to people that may take actions because of it, is a noble thing in monitoring. And we can get into, we'll get into a little bit more of what's the legal ramifications of that. But important. So here's, I've listed just benefits of real-time monitoring that I see in my work. And the last point I think is really interesting, that a lot of my clients maybe squawk in the beginning when they get forced into monitoring, but then they do it. And after a while, on the business side, they get used to having the data and they find innovative or interesting uses for the data that can help them run their business or save money. And maybe I'll throw out an example or two. One of my clients, they don't operate anymore, but was an aluminum smelter. And they had a hydro dam exclusively dedicated to sending power to the aluminum smelter. And so it took like 250 megawatts to run their pot lines at this smelter. And they learned that they had a met station online, and the bigwigs at the corporate headquarters, which I think was in New York City, would look at the met station and say, boy, it's minus 20 degrees there today. Maybe we're not going to pour our electricity into heating our 50,000 tons of bauxite a day. We're going to sell that power on the open market today. And then tomorrow it's not minus 20, it's 30 degrees out. So it's 50 degrees warmer, and the amount of power they need to smelt their aluminum is way less. And then they would make aluminum that day. And then so what started out as just a little bit of a met station for, tag along with their particulate monitoring turned into a really useful business tool for them. So I see this kind of thing quite a bit. I don't know if you experience that at all, if there's anything in there the company finds useful, but sometimes there is. Okay. Yeah. And then maybe the other example I would use is just remediation. lot of times when they're remediating Superfund sites, they will actually use the monitoring to determine what they're going to do that day. So if it's dry, not humid, dusty, windy, maybe they're going to choose what they're going to do that day depending on what the weather's doing or what the site conditions are. So they don't necessarily do their nasty work on the windiest day of the year and then generate a ton of complaints that could have been avoided. So I see things like that. Just wanted to throw up some downsides of real-time monitoring and publishing of the data. Of course, there can be some downsides. If you have high readings, people see that. Maybe you have some alerts or alarms that get sent out via text or phone or email or to the public. You know, nobody wants to see that. Maybe there's some problem with the machine or the system and it throws out some erroneous data that you would clearly catch and invalidate later. But if it's published real time, that number went on the internet and people are looking at it theoretically, something to think about. Problems are obvious, and when you do have problems, you want to get on it and fix it because nobody wants to see errors on your website persist for a month. And then getting to my point there just a minute ago, once real-time data is available, people get really used to seeing that and they don't like to go backwards. So people don't want to see that last for 1 year and then stop. In my mind, once you start this and you're publishing, you're a little bit committing to the world that you're kind of going to do this forever. So I think that's a point to think about, is that do you really want to run your monitoring station forever? That picture, just to say it, is a tall net tower that transmits data. This is upwind of a wind farm and about 20 miles. And we have a 100-foot tower, so a 30-meter tower with multiple levels. And the utility uses this upwind data to predict about a half an hour ahead of time what their output of their wind farm is going to be. And then if the wind farm or if the winds kind of die down, they have a standby gas-fired generating station that they can fire up and have online by the time that low wind, so they're load balancing with the Met station. So kind of an interesting use for real-time data. So again, I was just using particulate samplers as an example of, I think, of a great candidate for more mass monitoring out there. Just threw this out. I don't know how familiar you guys are with particulate monitors, but there's kind of a huge range of what you can do for particulate in terms of cost and effort. You know, the BGI PQ200s, the modern low flow filter based particulate samplers, those are about $15,000 a piece. Both stations have 2 or 3 samplers. Somebody's got to go out there, change the filters, send the filters to a lab for pre and post weighing, etc. There's a lot of money there, and there is no real-time data that comes in the form of lab reports that then get published in monitoring reports. That could be weeks or months later. Now they have these TOMs and BAMs. Those have been out there for a long time. Very expensive. My high dollars, so these are tens of thousands each. BAM or TOM is about $25,000 each. Really difficult to deploy a lot of these machines and have good coverage. And then you have some of the lesser cost machines that I have up here as professional grade that I think of as that I would use as a consultant to get real data or comparable data. They're real time, they're less costly, I can put out more of them. So medium cost, maybe they're in the thousands of dollars, not tens of thousands. But you can put those all online and people love to see it, and EPA loves to see it. And then you get down to what I generically call the purple air. Again, so we've seen the purple air, it's about $250. I read a study the other day, there's about 50 different brands now of low cost consumer grade particulate samplers out there. A lot of them do pretty well in comparison studies against the federal reference method machines. We actually have an old school meteorologist at my company who We've been talking about these and we've ordered a fleet of these and we have a bunch of these out there now. And he was so excited about when he bought one and put one in his house. And I just thought that was funny. He thought it was cool enough, even though it's old school, to get one. Maybe the point is you can go dollars wise from mild to wild on particulate monitoring and get pretty similar data. So when I say old school particulate equipment, this is what I think of. When I started working here, this is the kind of thing I worked on. And when I think about these environmental and social justice movements and, you know, community monitoring, this is not what they're thinking about. You know, nobody wants this. And just think of the effort to get here. And again, this was, I guess a lot of my monitoring was for mines, but just to get there. And now you're climbing on the roof of this. Isn't even any railings or a ladder or nothing. I mean, it's just like, nobody wants this, right? This is not what people are doing. So you've probably seen these. These are the federal reference method, PM10 and PM2.5, low volume samplers. But you still got to go there. You still got to change the filters. This is the reference method. So they take this data that comes from these as gold. So the EPA, in evaluating other machines, compares them directly against these to see if they can compare. A lot of the newer technologies are not gravimetrics based, so they're not weighing a mass gain on a filter. They are light based, light scattering, or beta particle attenuation. So they're approximations. So they sometimes need conversion factors and maybe depending on the type of particulate needs some other adjustments, but the next slide here. These more modern machines can do pretty dang good. Oh, smoke. I bet we've had about 2 months of smoke in Montana now. I don't know if you've ever seen any of these. This is a T-ohm. And then in that shelter is a BAM. So this is a kind of an automated microbalance. So this is actually measuring weights. BAMs are using beta particle attenuation. The downside of these is they're really expensive to be in a heated and air-conditioned shelter. They are not mobile. They take a ton of power, etc. That's just a little cabinet, but most of those are actually housed in a shelter building. It's probably a little bit like the pad on the ground there. Very expensive to put one of these up, not mobile. States can't afford to put out fleets of these. And then there's kind of the smaller stuff that is more affordable. These Esamplers is a light based basically particle counter. Those are made by Met1 in Oregon. Again, these are just examples, but the purple area, I don't know if you guys actually seen one in real life. I mean, they're pretty dang small. It's actually mounted in a PVC pipe with a cap. I mean, the guts are like this big. And there's actually 2 sensors in there that they run side by side. So if one of them drifts away, you can see it. But again, for $250, anybody can buy a Purple Air, screw it to a post, plug it in. They do need AC power. They're Wi-Fi enabled. You put it on the internet and boom, you're monitoring and publishing and recording data in about 10 minutes. So real-time data has to be reported somehow. There has to be a communications network. There has to be data storage. There has to be some way of publishing that. There's a whole host of different ways you can do this, but Wi-Fi and cell modem are super common and relatively easy. Not necessarily the cheapest things in the world because there's ongoing costs, but easy to do. At a plant site, I guess you have more options available to you there. And then the data has to go somewhere, right? It's got to be on a server. It's got to be in a database. It's got to be accessible. It's got to be published on a website if you're going to have it available real time. there's a lot of different ways to do that. I just think it really pays to think about how you're going to do that. Sounds like you guys probably spend quite a bit of money collecting that data and publishing it, which sometimes has to be. But there are other ways to do it, like this Purple Air and the Wonder Map. I'll just show you their websites here. They'll do it for free, and they'll take data even from not their instruments. They'll take data from any instruments and can put it on the web. So just it behooves you, if you're going to plan a network, to figure out how this is all going to work. So this is just a simple display of one of our online systems. This just happens to be our Met page here, where we would collect data at a site, maybe from all the sensors, put it on a server, upload it to a website. The ones we build are generally publicly accessible. And then in this case, there would be other tabs. That tab, all the particulates, everything else that they have. I know there's a million ways to do this. There's a million different kind of dashboards. You can design it any way you want. But I think it's important to think about, if you're putting the data out there for public consumption, what you're throwing out there, and maybe what the skill level of the audience is reading it. I can read a lot into this. Clicking over the tabs, do you want to show just the data? Do you want to show historical data? Do you want to show alarms? Do you want to show history of alarms? Do you want to show all the other compiled data reports? You can go on and on and on of what you want to show. But I think, again, it just behooves you to think about who your audience is and what you're putting out there a little bit. So I don't know if you guys have looked at the Purple Air site, but they have a map. Once you buy a Purple Air and put it online, you can elect to make it private or public. And if you make it public, it will publish the data on their Purple Air map. So I took this snapshot here of Austin the other day. I just think there's a lot of interesting things going on here. Hey, there's a whole bunch clustered in downtown Austin, so it looks like there's about 20 Purple Airs running in downtown Austin. It strikes me that they all read about the same. It strikes me that on this particular day, which is about 3 days ago, Austin's air quality wasn't all that good. I can see that there's no indoor air quality stations. These are all outdoor air quality stations. And that clustered downtown or a little further out of town, it's all about the same. So maybe the wind direction in here isn't so important as much as either A, there's a lot of urban emissions here. Maybe it wasn't a windy day, or B, I guess I'm not really sure if you guys are impacted by wildfire smoke here in Texas, but to me, that smells of either wildfire smoke in a rural area or urban air pollution in a urban area. There's thousands of these Purple Airs in the United States. So again, you could get yours on there. It logs the data, it collects the data, it displays the data. There's a historical tracker. You can go down and download the data later. You can graph it all. It's pretty crazy what you can do. And it's basically free. Once you buy the Purple Air, you're online here for free. So when I think about community monitoring, I think of things like this as genius. And it really is available to anybody. And I showed you the slides of some of the money that EPA is granting. They could buy a whole ton of these things if they wanted to, and you could have some really clustered, localized monitoring about anywhere. So if that's around your plant, I think it would behoove you to know what's going on around your plant, because everybody else knows what's going on around your plant.
Okay, I was looking at my phone, Air, I have the IQ Air app.
Mm-hmm.
And so that is Air,
Yeah.
I didn't realize this, I mean, I'm in the area, but it's got like 5 sources. Air,
Yep. And
Generally, yeah, I started using wildfires.
yep. And I use this example. There is a ton of apps and other companies doing this. I think this is one of the more forerunners, and this is one of the more popular ones. But yeah, even the EPA, you go to EPA's Air Now site, you can click all your little switches. You can turn purple air data on EPA's Air Now website, which I almost think is crazy, but I think they're basically saying, this is decent data, and let's have the people know what it is. Another one maybe you guys have looked at before, but Weather Underground, the Wonder Map, takes it a little bit further. You can see there different air quality data and from where, but it also adds in people's home net stations. So you can also get a giant net data set out of Wonder Map here. If you want to, and granted, these are, mostly home-based kind of cheap met stations, but again, there is a giant fleet of these things out here in Austin and everywhere, really. This data is all available, and it's usually pretty good. So again, I think it behooves you to do some surfing around and see what's out there. There are other programs, there's all kinds of programs, and I think, the Internet of Things really gets, to me, this is what it gets at is, if you can link all these data sites and make it publicly accessible, at some point it becomes really useful. Let's see here. I just threw this up here. So we are a consultant. We build and operate ambient air stations. Sometimes it's not obvious at all what some of these things would cost if you hired a consultant to do that. So I just threw this slide up there to give people an idea of what you're looking at for basic monitoring. One site for each of these examples, but you can see in my first example, if you have to throw up NOx, SO2, maybe ozone, a Met tower, and a couple of particulate samplers, that's $250,000. It's not cheap. And then once it's built and operating, you're probably looking at another 100 or 150,000 a year to run it every year for one site. You can see the prices there. The price for a tall Met tower, if you had a big stack and you got forced into modeling a tall stack, that is real money. And it probably costs you about that much to run it every year as well. Contrasting with if you have a community group that wants to just monitor locally, you can buy a Davis weather station, which we recommend as a consumer grade unit. Put up a purple air and a Davis weather station, and you're monitoring Met and particulate for under $1,000, and it's hosted on the web forever. So there's a huge range of things you could do. So I think as an industry, again, getting back to the environmental justice end, maybe somewhere in there you can wrap your head around those costs and efforts, but really should think about doing that. And I think, the cheap costs of all this consumer grade stuff, it really does lend itself to clusters of monitoring, and we're going to have way more data in the future everywhere. So again, just be prepared and know what goes on around your plant, because everybody else is going to know. And again, I focused on particulate here today, but there are tons of other sensors for other pollutants coming online. We actually have been talking with Purple Air. Purple Air is coming out with NOx and VOC samplers about on the same cost range. So now maybe your neighbor could throw up a NOx monitor next to your plant, or a VOC monitor, or all these other specialty chemicals. The stuff is all coming, if not already here. I just threw a table here of websites and places you can get some of this information. So if you guys want a copy of this, I could send you to you. You can see all these. There's a ton of resources online now. But one thing I would recommend, the very top one, if you haven't looked at it, EPA's AMTIC website has all of the official everything about monitoring in one place on one website. I don't know if you're familiar with the EMC, the emission measurement site for stack testing. It's kind of the same thing. Everything under the world for stack testing in one site, super handy. So just Google EPA AMTIC and it'll take you there, and damn, everything they've ever done is right there. And that is my last slide there. So happy to take questions or have some discussion or anything else. Let you go.